Oh, hey guys. Today we're going to talk about basic inequalities. So hopefully this will be really a very simple lesson for you. What is an inequality actually? An inequality is a statement that two quantities are not equal. Okay, we've been talking about equality for the whole first semester and now for the whole second part of this first part of the semester. Now we're going to look at what an inequality does. Okay, so the types of inequality symbols that you will encounter are this thing. This is a less than sign. Okay, so A is less than B. All right, we can call it less than. Okay, generally speaking, when something is less than something else, this is a number line. Okay, you would write, if this is, let's see, this is, we'll just, less than is going to go to the left, okay? And it's not going to have, it's going to have this parentheses, okay? So parentheses and to the left. Okay, then we've got this symbol. This is greater than. So A is greater than B. Looks like this. Greater than. Okay, and if we had it drawn, okay, greater than means it's to the right, but you don't include the endpoint. Okay, because if something is greater than something else and it's not equal to it, then it's going to be bigger. So we're not going to include the endpoint. Your book will have an open dot instead of the parentheses, but when you get up in a higher level math class, the parentheses are what you use. So now that we're in high school, I expect you to use the parentheses when you're not including the endpoint, okay? We also have less than or equal to. Okay, when you have less than or equal to B, A is less than or equal to B, less than or equal to, okay, that means that you include the endpoint. So here we have our number line. So I would include, A is less than, so we're including and it's going to the left, okay? Your book would have a closed dot to the left. All right, then we have greater than or equal to. So if A is greater than or equal to B, we would write it as greater than or equal to. Okay, if I had a number line here, I would use a bracket like I have over here, but I would shade to the right. Your book would have a closed dot and shade to the right. Okay, so a bracket and a closed dot are the same thing. A parentheses and an open dot are the same thing. You have to make sure that when you draw the bracket, it looks like it's a square bracket so that I know and you know that you're including the endpoint. You also have the symbol not equal to. That kind of came off of there. Okay, not equal to. If A is not equal to B, then not equal. Okay, then we would have on our graph, instead of shading anything, we would just have an open dot, okay, an open point. Another way you could write it is parentheses that look like that, okay, because you would have going from this direction, you would have arrows coming from this direction. I need a different color. So arrows coming from this direction, open parentheses, arrows coming from the other direction. The only spot that I'm not including is the place where my parentheses are. Okay? All right, to solve solving inequalities, a solution of an inequality is any value of the variable that makes the inequality true. Okay, now for equality, we usually only had one solution. Okay, for inequalities, we're going to have infinitely many solutions usually. Okay, so you have to keep in mind these are not functions, these are inequalities, okay? All right, so here we go. What happens when we multiply both sides of an inequality by a negative number? Well, you would all agree with me that 1 is less than 8. 1 is if I drew a number line, okay, 1 is here, 8 would be way over here. Okay. Now let's just multiply each of these by -1. Both sides. I can do that, right? I can multiply both sides by the same thing and not get in trouble. All right, so -1 times 1 is -1. 8 times -1 is -8. But if I keep this inequality symbol here, is -1 less than -8? Well, remember, less than means it's to the left of -8. So if I came over here and I drew this in, here's -1, 0's right in the middle, okay? -8 would be way down here. Is -1 to the left of -8? No, -1 is greater than -8. So when you multiply both sides by a negative, you have to flip the inequality symbol. Okay, so multiplying both sides by negative means you have to flip the inequality symbol. So how do you solve inequalities? The first step, most of these steps are identical to solving an equation. So the first step is to isolate the variable on one side of the inequality symbol. If it's on both sides, you have to get both of them on the same side, which would require you to probably subtract one of them from both sides, okay? If you ever multiply or divide both sides by a negative number, you must flip the inequality symbol. Okay, so whatever it is, just flip the thing. Then you graph the solution set on a number line, and then write your answer in interval form. Okay, I'm going to expect you to write them in intervals. We've done that to a certain extent before, so here we go. Solve each inequality and graph the solutions and give the solution in interval form. All right, so here we go. I've got x over here. Just like this was an equal sign, I'm going to solve for x. So I'm going to subtract 9 from both sides. Draw a line. X is less than 6. Now, I didn't multiply or divide by negative, so this is still true. My important number is 6. And I'm going to put the two numbers that are next to it, 5 and 6. Now, 5 and 7. Now, which one is smaller than 6? Well, 5 is smaller than 6, and I'm not including the endpoints. So this is going to be a parentheses. Let me get a different color. A parentheses at 5, and I'm going to shade to the left. Okay, now that I have my graph, I'm going to write my interval form. I'm going to read my graph from left to right. At the leftmost area, I see an arrow, which means it keeps going, so that would be negative infinity because it's going towards the negative area. This is negative side, okay? I keep reading and it stops at 5, and the thing that's on my graph is a parentheses. It's not including 5, so this is my interval form. Okay, just read your graph from left to right, and if you did it correctly, you'll have the right answer for interval form. It's great. Okay, let's try the next one. Well, m is divided by 3. So in order to get rid of the 3, I have to multiply both sides by 3. So 3 times 2.4 is 7.2. Because 3 times 24 is 72, and that's just one decimal over. Is less than or equal to m. Now, did I multiply by a negative? No. I just multiplied by a positive number to get rid of the number in the denominator. So here we go. I've got 7.2. That's my important number. I'm going to go one decimal to the right, 7.3 and 7.1. Okay, which one is m? M is bigger. See how the alligator is eating the m? The alligator wants to eat the bigger number. So m is bigger than 7.2, and we're including 7.2, okay? So which one's bigger? Well, 7.3 is bigger, and I'm including 7.2, so I'm going to shade to the right. Okay, now I'm going to read it and write my interval form from left to right. Nothing, nothing, nothing. Ah! Square bracket. 7.2, comma, keeps going until I get an arrow. That's positive infinity since it's heading towards the right. And there's my answer. Okay. Ooh, lots of fractions. Like it, like it, like it. If you remember, last semester we talked about how to get rid of the fractions really easily. I said if you multiply both sides by the least common denominator, you would have no more fractions. So that's what we're going to do. The least common denominator here is 20, so I'm going to multiply both sides by 20. 20 times 3/4, the 20 divided by 4 is 5. 5 times 3 is 15r. Okay, then I have to distribute to the other one. 20 times 2/5. 20 divided by 5 is 4. 4 times 2 is plus 8. Is less than 20 times 12 is 240. Okay, now I just have to solve for r. Minus 8 on both sides. 15r is less than 232. Now I have to divide by 15. And let's see. A mixed number would be helpful here. And I'm going to do that. Okay? So, especially with the number line, it would be very helpful. So let's see. 232 divided by 15. 23, I can get 1 out of that. That gives me 8 and 2. And I can get another 3, 4, 5. And that would be 75, which gives me 7. So 15 and 7/15. All right, so that's my big number, 15 and 7/15. That's my really important number. And numbers to the side of it, we've got 16 and we've got 15. Those are the numbers bigger and smaller than that, okay? Notice I'm just helping myself get myself anchored on the number line, okay? I'm just giving myself a place to look. I'm not really worried about, you know, how many numbers I'm drawing here. Okay, it tells me that r is less than 15 and 7/15. So I'm not including 15 and 7/15, and I'm going to the left, putting the arrow on my end there. Okay, when I read from left to right, I get to the arrow first, so that means negative infinity, la 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 la, all the way to 15 and 7/15. And I'm going to just write it in improper form if you don't mind. So 232 over 15, and I'm going to put a parentheses around it. Now you could write it in mixed number form. Either way, it doesn't really matter. Okay, this is simplified as it is because this is not divisible by 3. Okay? All right, so now we have that one. Ooh, D is much easier. I'm going to add 1 to both sides. So 3D is greater than 6. So D is greater than 2. I didn't divide by a negative, so I'm okay. 2 is my important number. 3 is to the right. 1 is to the left. It says don't include 2, but D is bigger, so I'm not including 2, and I'm going to shade to the right. So if I read it from left to right, I have open parentheses at 2. Keep reading, keep reading, keep reading. Arrow, positive infinity. Okay, yay. Okay. All right, letter E. I'm going to subtract 12 from both sides, and I get negative 2x is less than or equal to 8. Now, you probably have noticed that this is negative. I'm going to still divide by negative 2. I have x and negative 4. But I just divided by a negative, which means I no longer am less than or equal to. I have to flip the sign. That's the most important part of this example. You have to flip the sign when you divide by negative. So now I have negative 4 is my important number, negative 3, negative 5 is more negative. Okay. So I include negative 4, and x is bigger, so I'm going to go to the right. That's an arrow. All right, so I have include negative 4 to positive infinity. Done. Okay, the next one, there's a couple of different ways I could do this. I could distribute, or if I'm clever, I would notice that since 7 is being multiplied to the whole thing over here, I'm going to divide both sides by 7. And I would get x plus 2 and -6. Now, did I divide by a negative number? Is 7 negative? No, 7 is positive. So my inequality symbol stays the same. It's okay if this number is negative over here and I divide by positive. It's when I divide both sides by a negative number that I have to flip my inequality symbol. Okay, so -2, -2, x is greater than -8. So -8 is the important number. -7 is over here. -9 is over here. It says do not include 8, but x is bigger. So I'm going to shade to the right of 8. Okay, if I read it from left to right, include or do not include, oops, sideways 8, sorry guys. -8 to positive infinity. That one's really confusing, I know, with the 8s and the infinities, kind of scary. All right, so what to do next? Email me a list of 3 things that you learned or were reminded of, okay? One good question, unless you have more, and the subject line of your email needs to be Basic Inequalities Video. Okay, remember to send it to me in a brand new email, not an attachment to another one. Bring to class the filled out notes for Basic Inequalities, the completed warm-up questions for inequalities, and the completed cool-down questions for 6-4. All right, guys, see you later.